Hey guys, welcome to your Chapter 10 Lesson 3 notes on operations with radical expressions. By the end of the day, you'll be able to simplify sums and differences of radical expressions, but also products and quotients of radical expressions. Remember that sum means an answer to an addition problem. Difference is a subtraction problem. A product is a multiplication problem. And a quotient is a division problem. So let's get started. What we're going to do today is we are going to find like radicals and we are going to simplify them. So please read this as simplifying like radicals, not simplifying like radicals. Okay, here we go. So let's talk about a like radical. Like radicals are radicals that are alike. Brilliant, right? They have the same radicand. Remember, the radicand is the quantity underneath the radical. So here the radicand is 3. These are like radicals. Here the radicand is 2. These are like radicals. And the good news is you can treat it just like a normal algebra problem. Here, let's say we've got some quantity and we don't know what it is, but we've got a yellow box and we've got another yellow box. If I have 2 yellow boxes and I add them together, 2 of those plus one of these guys, how much will we have? We have 2 yellow boxes plus 1 yellow box. Well, that'll be 3 of whatever is in our yellow box. But now let's open it up. What was in our yellow box? Oh, our yellow box was a rad 2. So that means 2 rad 2 plus 1 rad 2 is 3 rad 2. It's the same kind of concept as if you have 2 times x, for example, plus another x. You've seen this before. 2x plus x is 3x. Same kind of deal. Cool. So our answer here is 3 rad 2. Subtraction works just the same way. Here, instead of rad 3, we can replace it with a yellow box, right? If you have 10 yellow boxes and you subtract 4 of whatever is in your yellow boxes, well, how many will you have left? Well, you'll have 6 of whatever is in those boxes. But what's in the box each time? Oh, rad 3. So 10 rad 3 minus 4 rad 3 is 6 rad 3. That's it. Okay, let's do 2 examples. First, we need to check that we have like radicals. These are like radicals because they both have an 11 under the radical. So this is the same thing as 6 rad 11 plus 9 rad 11. Woohoo! That'll end up being 15 of those guys. So you have 6 rad 11 plus 9 rad 11 equals 15 rad 11. Another way to think about it is like you took this rad 11 and you distributed him out. So you're left with 6 plus 9, and then on the outside you've got a rad 11. 6 plus 9 is 15, so we're left with 15 rad 11. Cool? Same thing over here. 1 rad 3 minus 5 rad 3, well, that's the same thing as 1 minus 5 all times rad 3. 1 minus 5 is negative 4, so we get negative 4 rad 3. So that's addition and subtraction. You can add and subtract like radicals, just like normal algebraic expressions. Multiplication gets a little more fun. First, we want to get like radicals. Here, these are not like radicals. Rad 3 and rad 12, they have different radicands because 3 is not equal to 12. But we can make it a rad 3, and here's how. So let's focus on just rad 12 for a little bit. Remember that rad 12 is the same thing as the square root of 4 times 3, because 12 is 4 times 3. Well, that's the same thing as rad 4 times rad 3. And guys, the square root of 4 is 2. So that tells us that square root of 12 is 2 rad 3. So I'm going to replace that right there. That was really messy. And now we're sitting in a good position because we have two like radicals, rad 3, rad 3. So we can pull a rad 3 out from both of them. We have 5 minus 2 rad 3's. 5 minus 2 is 3, so that gives us 3 times the square root of 3. How cute is that? So cute. Sweet. Now on this side, we're going to do some multiplication. And it works, we're going to distribute. It works just like normal. So we're going to distribute rad 10 to the rad 6 and rad 10 to 3 to give us rad 10 rad 6 plus rad 10 not a rad 3, normal 3. Almost got you there. Cool. So that's the same thing as the square root of 10 times 6 is 60, plus all I'm going to do here is I'm going to rearrange 3 rad 10. Now let's focus on the square root of 60, for example, for a quick second. 60 is the same thing as 4 times 15. Remember when we want to simplify a radical, we want to find a perfect square inside, and 4 is a perfect square. So that's the same thing as square root 4, square root 15, that's 2 rad 15. This cannot be simplified anymore because 15 doesn't have any perfect square factors inside. So this tells us that rad 60 is the same thing as 2 rad 15. So I'm going to replace my rad 60 with a 2 rad 15. Oh guys, check it out. They're not the same. Oh well, guess what we do with that? Nothing. We just leave it as is. That's in the most simplified form. You cannot combine them. You cannot add them together because they are not the same radical. They're different, so leave them alone. We're all set. There's one more helpful little trick to help you when you have gross in the denominator. Because remember, in order to simplify a radical expression, there are 3 conditions that must be met. 1, you cannot have any perfect square factors. That's not okay. This is a no. Don't have these things. Next, you can't have any fractions. And finally, you can't have a denominator with a radical in it. And lo and behold, we have some radicals in our denominator. So we're going to find a new trick to help us rationalize the denominator using something called a conjugate. So conjugate, when you hear conjugate, think opposite, because conjugates are sums and differences of the same terms. For example, a classic conjugate, if you have A plus B, its conjugate is A minus B. Whatever those two terms are, you got a plus E, you got a minus E. Okay? So the conjugate of, x plus 2 is x minus 2. Or the conjugate of 5 minus the square root of 7 is 5 plus the square root of 7. All we're doing is we're changing the minus to a plus, the plus to a minus. Totally switch those. So how do we simplify this guy? Well, we need to multiply top and bottom by the conjugate of the denominator. So what's the conjugate of the denominator? Well, that's rad 7 plus rad 2. We'll multiply that on top and on bottom. Now what's super nice here is when you multiply conjugates together, they follow the difference of squares rule. Remember that guy? Yep. Oh wait, I didn't want to do that. Okay, you have the first term, if we FOIL this out, we would get a squared plus, minus a squared minus ab plus ab minus b squared. But those middle terms, those are going to cancel out. They all but gone because they're the opposite. So when you multiply conjugates together, you just get the first term squared minus the second term squared. They all follow the difference of squares rule, which is super great. That's going to help us up here because look it, guys. We've got our difference of squares. So on the bottom, that's just going to give us the square root of 7 squared minus the square root of 2 squared. And then on top, we've got 10 rad 7 plus rad 2. Now, rad 7 squared, rad 2 squared, those radicals are going to cancel out, giving us just 7 minus 2. How fun is that? And on top, we're going to distribute this 10 to each term, which gives us 10 rad 7 plus 10 rad 2. We're almost done, you guys. Best problem ever. Okay. 7 minus 2 on the bottom is 5. So we're left with 10 rad 7 plus 10 rad 2 all over 5. As a last hurrah, 10, 10, and 5, they're all divisible by 5. So that'll leave us 1 on the bottom, 5 on top, and 5 on top. Dun, da, da. So our final answer is 5 rad 7 minus 5 rad 2. Great, right? So great. So you can use conjugates, which are basically opposites, to help you rationalize a denominator. You can add like terms, and you can have a wonderful time on your homework.